Leafcutter Ant documentary, Small but Mighty. In the dense rainforests of Central and South America, a remarkable civilization thrives beneath our feet. The leafcutter ants, despite their diminutive size, have built one of nature's most sophisticated societies, a testament to the extraordinary power of collective intelligence and evolutionary adaptation. These industrious insects demonstrate that true strength lies not in individual prowess, but in the coordinated efforts of millions working toward a common goal. The Underground Empire. Leafcutter ant colonies represent some of the most complex social structures in the animal kingdom. A single mature colony can house between 3 to 8 million individuals, all descended from a single queen who may live for up to 20 years. Their subterranean cities stretch across vast networks of tunnels and chambers, some extending over 600 square meters and reaching depths of 6 meters underground. What makes these colonies truly extraordinary is their division of labor. Within each colony exist distinct castes of workers, each perfectly adapted for their specific role. The smallest workers, called minims, tend to the precious fungus gardens that serve as the colony's primary food source. Medium-sized workers, known as medii, handle the transportation and processing of leaf fragments. The largest workers, the majors, serve as living fortresses with their massive heads and powerful mandibles, defending the colony from threats and clearing pathways for their smaller sisters. Masters of agriculture. Perhaps the most fascinating aspect of leafcutter ant society is their mastery of agriculture, a practice they perfected millions of years before humans ever planted their first seeds. These ants don't actually eat the leaves they harvest. Instead, they use them as compost to cultivate a specific species of fungus that serves as their primary food source. The process begins when forager ants venture out to select suitable vegetation. Their choices are remarkably sophisticated, as they must consider factors such as leaf toxicity, nutritional content, and fungal compatibility. Once harvested, the leaf fragments are transported back to the nest in an impressive display of teamwork. Smaller workers often ride atop the leaf fragments, protecting the carriers from parasitic flies that attempt to lay eggs on the exposed ants. Back in the colony, the leaves undergo a meticulous processing routine. Workers clean the fragments, chew them into a pulp, and apply enzymes and fecal droplets that contain essential nutrients for fungal growth. This processed material is then carefully cultivated in specialized chambers where the fungus grows, creating protein-rich structures that feed the entire colony. Engineering marvels. The architectural achievements of leafcutter ants rival those of human engineers. Their nest systems feature sophisticated ventilation networks that maintain optimal temperature and humidity levels for fungal cultivation. The ants create airlocks and thermal chimneys that regulate airflow throughout the colony, ensuring that their fungus gardens remain in perfect condition. These underground cities also include waste management systems, nurseries for developing larvae, and specialized chambers for different activities. Some chambers serve as staging areas for foraging expeditions, while others function as processing centers where leaves are prepared for the fungal gardens. The precision with which these spaces are constructed and maintained demonstrates an understanding of engineering principles that continues to amaze researchers. Communication and coordination. The seamless coordination of millions of individuals requires sophisticated communication systems. Leafcutter ants primarily communicate through chemical signals called pheromones. When a forager discovers a promising food source, she lays down a chemical trail that other workers can follow. The strength of this trail indicates the quality of the find, allowing the colony to efficiently allocate its workforce. The ants also use tactile communication, touching antennae to exchange information about their current tasks and the colony's needs. This constant flow of information ensures that resources are distributed optimally and that potential threats are quickly addressed. The result is a superorganism that can respond to challenges and opportunities with remarkable speed and efficiency. Environmental impact and ecosystem role. Leafcutter ants play a crucial role in maintaining the health of tropical rainforest ecosystems. Their constant harvesting and processing of vegetation helps cycle nutrients through the forest floor, enriching the soil and promoting plant growth. A single large colony can process over 40 tons of vegetation annually, making them one of the most significant herbivores in their ecosystem. Their abandoned nests create unique microhabitats that support diverse communities of plants and animals. The nutrient-rich soil left behind becomes fertile ground for specialized plant species, while the abandoned tunnels provide shelter for various small animals. In this way, leafcutter ants serve as ecosystem engineers, continuously reshaping their environment in ways that benefit countless other species. Lessons from small giants. The study of leafcutter ants offers valuable insights into sustainable living and efficient resource management. Their closed-loop agricultural system, where waste becomes the foundation for food production, provides a model for circular economy principles. Their ability to maintain stable populations while efficiently utilizing available resources demonstrates the power of cooperation and specialization. These remarkable insects remind us that size is not the ultimate measure of success in nature. Through millions of years of evolution, leafcutter ants have developed solutions to complex problems that human societies are only beginning to understand. Their underground civilizations stand as monuments to the power of collective intelligence, proving that sometimes the mightiest forces come in the smallest packages. In observing these tiny architects, farmers, and engineers at work, we gain a deeper appreciation for the intricate web of life that surrounds us and the remarkable adaptations that make survival possible in our complex world. Thank you for watching. Don't forget to like, share, and subscribe for more videos.